Well, we have another question here, question 4.2. The question says that the graph of f of x equal to a half times x plus 5 to the power of 2 minus 8, and g of x is a half x plus 9 over 2 are sketched below. A is the turning point of f. The axis of symmetry of f intersects the x-axis at E and the line G at D. C is the y-intercept of f and excuse me, and G. Now, question 4.2.1 here says write down the equation. Excuse me. Write down the coordinate of A. Okay, so we need to find the coordinate of A. This point here. Okay, so that's I'm gonna write the question over here. Question 4.2.1. A are like x, y. Okay, those are the coordinates we need to find. The equation f of x equal to a half x plus 5 to the power of 2 minus 8 is called the turning point form of a quadratic equation. Okay, because the values here and that determines the. Okay, maybe I should write it like this. I'll write my formula like this. Y equal to A open brackets x minus p to the power of 2 plus q are what we call the turning point form of the quadratic equations. So the values p and q determines the coordinate of the turning points. Okay, they determine the coordinate of the turning points TP. So in this situation, because like f is expressed by a half x minus actually plus 5 to the power of 2 minus 8, we understand from there that the turning points here are -5 and -8. Okay, -5 and -8. So you may say it's +5 here, but if you look at the formula, you have minus. Okay, so plus here it's like -5. So the x coordinate of turning point is -5. So A is -5 and -8. Okay, and then the following question is question 4.2.2. The question says that write down the range of f. Okay, now right here 4.2.2. We're looking for the range of f. Okay, what is the range of a function? The range of function is all the acceptable y values. So if you look at this f here, f is what we call, it is a parabola. Okay, so it can take not all y values, because as we did find the turning point to be the turning point, we did find it's like -5 and -8, meaning it will only have like the lowest value of this graph. Okay, will be -8. Okay, the lowest y value will be -8. So we'll say the range will be y is greater or equal to -8. It cannot be below -8. Or sometimes people can write it like sorry about that. Or people can say y is elements of the interval from not open round bracket but square brackets here, -8. Oops, -8 to infinite. So one sending 8 and another slipping 8. Not square bracket there, but round brackets. Yes. The following question is question 4.2.3. 4.2.3, the question says calculate the value of n and of calculate the value of m and n. Now, we can notice that as the question says that the axis of symmetry of F intersect the x-axis of E at and the line G at D, M, N. So they have like A and D here have the same x coordinate. So M here is -5 clearly. Okay, so we can write here like question 4.2.3. We're looking for M and we're also looking for N. M is equal to -5. Okay, and then how can we get N? We can just find N if we sub in N is the y coordinate, so we can just sub -5 into the equation here. Okay, G in the function G, excuse me, y is just equal to 1/2 x plus 9/2. So if we sub in the value of the x coordinates of this, which is -5, I'll sub here -5, and then that -5 was not, it's not that visible, but if I sub -5 there, we'll have like -5/2 plus 9/2. Now that the denominator are common, okay, we have 2 there, 2 there, we can just add the numerator. We're gonna do -5 plus 9, and that's equal to 4. 4/2 is 2. So okay, I sub, let's just write like this one. I sub m -x for -5. This is n, okay? This is n, the y coordinate is n. So n is just equal to n equals to 2. M is -5, n is n, m is -5, and n is 2. Now, the following question is question 4.2.4. The question says calculate the area of OCDE. OCDE. Let's see. What area is that? Okay. So OCDE. So this area we need to calculate the area in here. How can we do that? It has the form of a trapezium. Excuse me. It has the form of a trapezium. I think I need to reproduce the same diagram over here because this is where I will do it. Sorry. 4.2.4. So we're looking for the area OCDE, the area of a trapezium. Okay. Okay, let's just look here. What do we know? Because we said it's area of a trapezium. What do you know about the area of a trapezium? What's the formula for the area of the trapezium? I say the area of trapezium is given by 1/2 times lower base plus the other base, the longer base, okay, times the height of the trapezium, so times h. Okay. So what is A, what is B, what is h here? Okay, we're talking about the upper and lower base. Okay, so the base are here, this one and that one, because this trapezium is like sleeping trapezium on, so it's like this is the lowest, that the bigger base, and then this is the height of the trapezium. So it's like that's the points was DS DE plus OC. So it's like OCD. So OCDE will then be R1/2 times DE plus OC, okay, times OE. Am I correct? Double check. Yes, OE is the height, DE, OC. Okay, I'm correct. Then let's now find these heights. What is the length? So what is OE then? I mean DE. We know the coordinate of because they are verticals, okay, the vertical lines, we will just consider the y values, okay. So n was found to be 2, and then E lies on the x-axis, so it's just 2 units. There are just 2 units. So this will be equal to R1/2 times 2 plus, and then OC again. OC here, O is on the x-axis at the origin, and then C, how much C? Okay, we didn't calculate C, but we can find the value of C if because C is the y intercept, right? So we can find it here. It is 9/2. Yes, because the y-intercept is 9/2. This value here, the constant term of the straight line, even quadratic, are just the y-intercept, so it's just 9/2. So 9/2 units plus 9/2, okay, multiplied by OE. OE is also at the origin, and then E is because this is horizontal line, okay, we're going to consider only the x values. So here the x value is 0, and then that's the x value is m. M was found to be -5, but because it's length, we're just going to take the absolute values, meaning the numbers without the signs, okay. We're going to take 5, so this is going to be times 5, and then this will make what? So we're like R1/2 open bracket, that makes 2 is like 4/4, 4/2, excuse me. 4/2 is 2, so plus 9/2 times 5, and then this is equal to R1/2 times 13/2 times 5, and then 1 times 13 is 13. 13 times 5 is equal to 65 over this. All this makes 65/4 square units. So units squared, that's the area OCDE. Okay, and then comes the next question. Question 4.2.5. Okay, what does it say? Okay, the question says that determine the equation of G minus 1, the inverse of G in the form y equal to. All right, G is a straight line, and then it's given by ½ x plus 9/2. So we're looking for G minus 1 in the form y equal to. Okay, now the function G is given by y, excuse me, the function g is given by y equal to half x plus 9/2. Okay, and then excuse me, and g minus 1 then it's when we switch the variables. Okay, we call y x, and then we're gonna call x y. So like x equal to half sorry about that, is a half y plus 9/2. Now I can move let's just reverse the order. It's going to be a half y plus 9/2 equal to x. So if I move 9/2 over, okay, qu'est-ce qui se passe? Oh là là, technical equal to x. Okay, so we can times the whole equation by 2. Okay, if I times each term here of the equation by 2 times by 2 times by 2 times by 2, just to cancel, I times by 2 because I want to get rid of a fraction. Okay, I'm not that comfortable to work with fractions, and then this will make y plus 9 equal to 2x. If I move the 9 over, you're like 2x minus 9. So this is g minus 1 in the form x equal to. Okay, and then the following question is question let's see, question 4.2.6. The question says that if h of x equal to g minus 1 of x plus k is a tangent to f, determine the coordinates of the points of contact between h and f. Okay, let's do it here. Question 4.2.6. So we say that h of x equal to g minus 1 of x plus k. Okay, they said h of x is a tangent to f. So we need to determine the coordinate of the points of contacts between f and h. All right. What can we do then? Okay. We do that g of x. Okay. G minus 1 of x is 2x minus 9. Therefore, g minus 1 of x plus k will just be equal to 2x minus 9 plus k. Okay, so all this is h of x. So h of x is just equal to 2x minus 9 plus k. Now, there are some properties for a tangent line. Okay, a tangent line, okay, a function h may have a function f can have a tangent line if the derivative of the function is equal to the gradient if the derivative of the, okay, what am I saying? Let me write what I'm saying. Maybe I won't make that much sense. If I have like a function f of x, okay, the gradient of the tangent line is equal to the derivative of the function. Yes. So we know that the gradient of the tension line, I call it like that, will be equal to the derivative of this function here. Here, the gradient of the tension line is 2. Now, we must prove that the 2 is equal to the derivative of f. Now, f of x was given by 𝐻. Let's see it again. F of 𝐻, open bracket x plus 5 to the power of 2 plus minus 8. I wrote it somewhere here. Okay, here it is. 𝐻 open bracket x plus 5 to the power of 2 minus 8. Now, let's write it again. So we have like 𝐻 open bracket x plus 5 to the power of 2 minus 8. Okay, we can expand this. This makes 𝐻 and then x plus 5 times x plus 5. Please don't do x squared plus 25, okay, because it's not exactly the same thing. Minus 8, and then this will be 𝐻. We will going to do 5 times x and x times 5, and then 5 times x and 5 times 5, and then this will make x squared plus 5x plus 5x plus 25 minus 8, and then this will make 𝐻 x squared plus 10x plus 25 minus 8, and this makes 𝐻 x squared plus 5x, okay, plus 25 over 2 minus 8. Now, excuse me. Okay, I don't really need to go further. We can just find the derivative from here. So f prime of x would be equal to find the derivative, we're going to find the derivative of this part, which will be 2 times 𝐻 times x to the power of 2 minus 1. Why am I doing that? Because I'm writing the derivative formulas here. A x to the power of n, derivative is just n times a x to the power of not x but a times x to the power of n minus 1. Yes, like that. So the coefficient, the exponents here 2 get down, times 𝐻 times x to the power of 2 minus 1. Okay, and then excuse me, plus 1 times 5, okay, x to the power of 0, and then plus 0. Now, it is important to note that 5x is like, oh la la, my 5. Okay, when you don't see any exponents on the x here, understand it's 1. So reason why I did right here 1 times 5x to the power of 1 minus 1, which is 0, and then this will make then you know, 𝐻 and 2 here we cancel out, and then we will be left with x plus 5, x plus 5. Now, therefore, x plus 5 here, which is the gradient of the derivative of f of x, this must be equal to the gradient of the tangent line, which is 2. So this is equal to 2. And then we can find the value of x if we move the 5 over. We move 5 over, and then we'll get x equal to -3. Now that we got the value of x, we need to substitute that value into excuse me, into either h here or f in order to find the y with the y coordinates. So because y equal to a half x plus 5 to the power of 2 minus 8, so that means y will be a half to the power of 2 minus 8. We sub in x there is -3, and -3 plus 5 is 2. 2 squared is 4. A half times 4 is 2. 2 minus 8 is 6. So y will be equal to negative 2 minus 8 is -6. Y will be -6. Therefore, the point of contact between the tangent line and the equation of f is -3, -6. Thank you.